All right. First of all, thanks for volunteering, Conrad. I know this is not the easiest thing to do, to code in front of not just perhaps me over the phone, but also some people over the internet, and that's it's always difficult. So, thanks for volunteering. I think it's going to be very instructive for people, and it's going to help people a lot when they see your thought process and see how you handle the various exercises that I have prepared here today. We did one last week with a different student, and just for the people who are in the audience here, very similar situation. Conrad is in course 101, but has been dabbling around and self-studying for quite a while now. And so he's not an absolute beginner, but he is in the very early stages of our program. And so I thought it'd be nice for him to kind of walk through some of these exercises. So I prepared a few, and I don't know how long these are going to take, Conrad. So if we get through these within the hour, that'll be it. That's all I have prepared. If they take over an hour, we'll probably just stop at the end of the hour. And for those of you listening in the audience, if you want to throw some bonus challenges at Conrad, if we happen to have time, let's say we finish 40 minutes in, I'm happy to take on some of the challenges that you present if Conrad is, and finish up the hour. Otherwise, we'll just call it whenever we're done here. And definitely feel free to ask questions as Conrad and I are doing this, and I'll try to, he won't be able to see the questions, but I'll try to relay your questions in our conversation. All right, Conrad, you ready?
Yeah.
Okay, we're in this Cloud9 environment. Can you just type something real quick just so I can see that you're in here? Okay, great. All right. And everyone at this point should be able to see what he typed. All right, so the first exercise here is going to be, give that a read real quick, Conrad.
Okay.
And okay. I see a small error in that. This should say GRN. And who wrote this exercise? And definitely a lot of typos here. Sorry about that. So it should just basically be the same words with the vowels removed.
Okay. Cool. So I'll just start by defining the method. I'll call it remove vowels. And it's going to take an array. We'll call it strings. And then we're going to want to iterate through, it seems to me, iterate through that array of strings and then remove remove all the vowels from the strings. I think I'll probably use the map method to do that. We'll use strings.map. Each parameter we'll call string. And then for now, I'm just going to return the string back to from the block, and then we'll see what that method as it stands returns to us. So I'll remove vowels. The array is going to be green, yellow.
And this is a real good strategy, running the code sort of ASAP.
Yes, I learned that from you last week in the last live session. Running it more often than I do. Example.rb. I didn't print out the method call. And it just gives us back that same array. So it looks like the map method is working the way I want it to. I just now need to actually do the logic in here in the body of the map method and get the right modified strings back. I think the way I'll approach it is I'll create a constant called vowels and then just list all the vowels in there. A, E, I, O, U, and we won't call Y a vowel in this context. So we have all the vowels in that context that we can use to determine if a character should be removed. Then I'm just wondering how to break the string down and then return it back. This is probably going to be a multi-line block, so I'll change that. I'm going to create a variable chars equals string, and then we'll split the string on every character. I'm going to go ahead and run that again and see what that returns. And it's an array of arrays, and all the individual arrays are each individual character, so that's looking good. And then I want to do chars. I believe there's a delete method on the on arrays. That would work well.
If you're unsure, you can definitely hop into IRB. It's completely open book, so
okay.
You can try things out in IRB if you would like.
Yeah, I'm checking the docs real quick, and delete looks like it'd be a good option.
Okay.
So we'll do IRB for a second. And if I have an array of strings, we'll just do this one to test, to play around with delete. And I want to delete E from it. Now it's returning B. Let's assign that to a variable so I can actually look at it. Oh, that's wrong too. I'm mistaken. So a delete actually returns the letter that we delete. So if we do this instead, B equals, and we do B dot delete, that's actually not going to mutate the original way. Okay, but it actually does. That makes sense. So that might be a good option. And then can I pass in multiple parameters to delete? Check the docs again.
And just for the audience, Conrad hasn't seen these exercises. I forgot to mention that. So first time he's seeing this.
It doesn't look like I can actually pass in multiple parameters to delete. It only takes one. But that does make me wonder if string has a delete method where I can delete certain characters. And I'm looking at the docs and it looks like it does. So maybe I don't actually need to break down string by splitting it like that. If I play an IRB again, it deleted all instances of T and E. So I think what I can do here then is I can just do.
And you don't have to do it all in one line. I feel like there's a solution here, and you don't want to take it because you feel it's repetitive.
Okay. I didn't see what that solution was. I missed it. So.
Well, you already know how to delete one character, right?
I'm sorry, say that again?
You already know how to delete one character, right?
Mm-hmm.
So that's the solution. Now you have a finite number of characters. You have 5 characters that you're testing against.
Mm-hmm.
So sort of the long way, I think you're searching for sort of a, if I can pass in the vowels array somewhere, right? That would be nice. But you already have a solution, which is not maybe suboptimal for now, but there is a solution, right?
Right. So what if I do vowels.each, iterate over the vowels array, and just do chars.delete vowel? That might do what we want. And then we can do chars.join with the empty string passed into join. Let me see what that's going to give us. Green, yellow, black, white. So that's passing back the array of all the strings with the vowels removed. So that works.
Right. That was it. I suppose if you wanted to, you can, instead of returning array, you can return a string. Right. Do one more join. But yeah, this is it. I guess I'm going to switch my focus to the audience now. Do you guys have any questions about this approach? So I'll make a couple of observations.
Okay.
So whenever you're coding, and Conrad is really fluent, so you can see how quickly he's kind of moving around. And when you're coding, you're always trying to take a stab at the problem or poke the problem, right? You're always trying to poke the problem. So notice how he sort of played around with the delete here, and I kind of noticed that he was trying to, have a pass in the vowels somewhere to delete all the characters in one thing, but he already had the solution. And you're only able to poke at the problem and try this and try that and see if this works and see if that works if you have the fluency to do so. What I see a lot of times is people who, it's not that they don't know, it's not a lack of knowledge, it's that they know all these concepts, but they can't move around very quickly. And so their first attempt at poking the problem, there's a lot of stumbles along the way. So for example, when Conrad tried to, so the first thing was split the string, split the chars into an array. Right? That's the first thing we'll try. And just doing that, a lot of people stumble here. And programming is very difficult if the fluency is not there, because your ability to code you can't keep up with your thinking speed. You're trying to think about all these different things, but your syntax is not fluent, right? And sort of analogy I always give is if you're trying to cook in the kitchen and you sort of know the steps, but your movement is just really clumsy, right? Boil some water. Okay, I gotta find the pot. I don't know where the pot is because I just don't know my way around the kitchen, right? I don't know the heats, the oven settings very well. Chop up some carrots and throw it in. Okay, it takes you 15 minutes to chop carrots, whereas a really fluid and experienced chef can do it in 30 seconds. So when every motion is a stumbling block and every motion is slow, it gets really hard to sort of discover or poke around the problem. As your fluency increases, you're able to sort of try this. Okay, that didn't work. Let me try another thing. Okay, that didn't work, but got closer. Let me try this other thing. Right. So that's generally what I see in the beginning stages here. And again, you saw how fluent Conrad was. He was able to keep up with his thinking. Right. He has ideas. He can execute them. Somebody said we can use regex, possibly. So here's the thing. Whenever you're solving a problem, always go for the suboptimal solution, but the clear solution first, and then refactor, right? There's always ways to make code better, I think, but always reach for the simpler solution first. Okay, so pretty good, Conrad. I felt like, you did this under pressure, and you did it in a way that I feel is very clear. You did a lot of running the code, and I could very clearly see your thought process. So overall, I thought this was a really good walkthrough of this exercise. Are you ready for the next one?
Sure, yeah.
Okay. This one's a little bit harder, I think. I haven't given this one to too many people yet. So actually, I gave it to someone. He came up with a real short solution, and someone else had a real hard time with it. So I'm not really sure how hard or easy this exercise is, but give that a read. Okay, so at first I don't want you to worry about the bonus. The bonus is sort of checking the order, right? So for now, it's just write a method that determines whether or not there is a balanced number of parentheses. And this type of thing is kind of important in code, especially in sort of data integrity. You're checking for making sure that you don't have a loose opening paren without closing it, right? So all it should do is just return true or false, depending on whether or not there's a balanced number of parentheses in the string that's passed into the method. and then we'll do the bonus later.
Okay. So I'll grab these to use these as my test case and comment them. So I'll just start by defining the balancer method. Takes a string. And the method is just looking to return a Boolean indicating whether there's a balance. So I would do string dot count opening parentheses equal to string dot count closing parenthesis. And I think that should do that for us. I'll print these out. And let's run that and see what that does. Define method balancer. I misspelled it in my method definition. True, false, true. So that looks like that's working correctly, yeah?
Yeah, so this is the fastest way. That's correct. So what about the bonus? What if we wanted to enforce the order?
In my mind, I don't see the solution to the initial problem seem pretty straightforward to me. I don't know that I see an easy way to do the bonus part. That to me seems a little bit harder, but let's take a stab at that and see if we can figure that out. I think we'd want to, initially we could just check to see if the number of opening parentheses is equal to closing parentheses. That'd be a good first check. And if that's not true, then we can just go ahead and return false. So I'm going to say return false unless string.count opening parentheses equal to string.count closing parentheses. So if there's not an equal number of opening parentheses as there are closing parentheses, we're just going to go ahead and return false at that point, because it doesn't matter what order the parentheses are coming. If there's not an equivalent number, then they can't be balanced. And we want to detect order is also good here. My first inclination is to say, let's iterate through the string. And yeah, let's just do that for now. I don't remember if you can call each on a string. Let's.
And I'm really glad you're testing out IRB, because again, I see so many people sort of write code with the assumption that it works, and they just keep writing. And we have 5 lines of code, and two things don't work right. So anytime you're sort of fuzzy, try an IRB. The problem is, I think, when a lot of people are fuzzy in a lot of places, and that's a real sort of pain if you're trying to work on an exercise like this, and there's lots of fuzziness. This is why it's important to build up fluency in the fundamentals. Sorry, go ahead, Conrad.
No, you're good. So you can't call each on a string like that, but we can if we split it. So if we split it on every character and then call each on the array that we get, that looks good. So I can iterate through the string if I just split it first. And here, what my initial thought to try is to check for either an opening or a closing parenthesis. And if we hit an opening parenthesis, I'll set a flag of some kind to say that we've hit an open parenthesis. And then as we go through the next parenthesis we hit should be a closing parenthesis. And if we hit another, but that won't quite work either, will it? Because if we hit a second opening parenthesis, that can be fine. it might work with this particular test case that we have, but it wouldn't.
Right. If you have nested parentheses, it wouldn't work.
Right. Nested parentheses are fine. So
I'll give you a hint. One way to do this is basically have some sort of counter, so that you start at 0, and the opening paren can increment the counter, and the closing paren can decrement the counter. And if you ever get into a negative situation, that means you're in a bad spot.
Okay. Yeah, that would work then with nested as well, because we could have up to, say 3 nested parentheses. But if we ever have more closing parentheses than we have opening, then that would be a bad sign.
Right.
That would be a failure.
Right.
Okay.
Or if you hit a closing first, that would be a negative.
Okay. So we'll start this at 0 paren count, and we're going to iterate through this string. And paren count plus equals 1 if char is equal to an opening parenthesis, and paren count plus equals 1 if char is equal to, not plus equals, minus equals 1. Char is equal to a closing parenthesis. I'm going to say, at this point, we can just evaluate what paren count is out. If it's at negative, then we'll go ahead and return false. I'm going to say,
it shouldn't ever be negative
return
at that point,
paren
right?
count.
Because by the time it reaches the iterator, each line 20, it should always be even.
Unless you have extra of 1, right? But I need to check earlier on is what you're saying.
Because line 16 is a guard. Basically, the only situation that can arise is if a closing paren occurs first.
Okay, I gotcha. Yeah, I'm mistaken on that point. You're right. I see what you're saying, because it's never going to be negative because we have this line up here in 16. This is already checking for equality. I'm just checking to see if we hit a closing paren first.
Right.
Or if we have too many closing parens first. No.
Not too many closing paren, just, you can have like open, open, close, close, then close again and open after that. Right? But you need to somehow, that's still balanced in terms of the count. Right? So, like this. If we have open, open, close, close, and then close, open, this is invalid, right? Because these 4 parens are a pair, that's valid. But then we get to invalid. The last 2 is invalid. But so this should return false. But you can't make that determination based on counting them, because it's actually an even count here. Right? So somehow here you have to, when you get here, you have to say it's wrong. Okay. Make sense?
So I think that makes sense to me. So I'm going to add a flag here called fail that we're going to check to set to false. And then we'll iterate through each character in the string. If it's an opening paren, we'll add 1 to paren count. If it's a closing parentheses, we'll subtract 1 from paren count. And then at this point, if paren count is less than 0, I'm going to go ahead and set fail to true.
Fail's a keyword in Ruby, so maybe choose a different variable.
Oh. It's not a horribly clear variable name. I should probably think of something better. Failure equals true. And then at that point, we'll go ahead and break. And then we can just return failure. I believe that's think that's good. Failure equals true. Then we'll break out of the iteration and we'll return failure. We've already checked that there's an equal number of opening and closing on line 16. That guard clause is good. So if we ever reach a point where we have more closing parentheses than opening, we know the order's out of whack. At that point, this line will execute, we'll mark failure as true, we'll break. And then if I return failure, though, it's going to be opposite. So we'll return not failure, but that's not horribly clear. Let's go ahead and run it and see where we're at.
Might have to add some extra test cases.
Let me add your test case down here. This one should return false. So let's see what that does. What do you think of that solution as of right now?
I think it should work. Well, let me just say, first of all, your workflow again is very good. I really enjoy watching you code, Conrad, because you don't make a lot of hiccups, you don't stumble very much, and the level at which you tackle these exercises is at the logic level. So again, sort of back to the audience, is whenever you're solving an exercise, you're always operating at two different levels. You're operating at one, the syntax level, especially early on. You're operating at the syntax level, trying to make sure that you can type, 2 lines of Ruby code that is not going to have any syntax errors. And second, you're operating at the logic level. Iterating between those two is very difficult because your brain is always kind of one step ahead of your ability to write Ruby syntax usually. As you can see here, because Conrad is so fluent in Ruby, he can actually just operate at the logical level without worrying too much about the syntax. And when there is a little bit of fuzziness, he hops into IRB and clarifies it. And that's a really nice place to be because you can then sort of tackle the problem based upon a higher level of thinking. And in order to do that, you have to have a fluency, right? And that's the part where it's just practice, right? It's just practice. So I think this is pretty good, Conrad. I don't know that you need a failure variable. I don't really have a major problem with this approach. You could actually just return out of this method on line 26 or 27 instead of setting a flag. You could just return out of the method. And remember, the return keyword will actually return from the method even if you're in a loop or iterator like each. Right, so you can say return false. Now, I don't completely disagree with your approach, although in this case it should be fine because you can actually just say something like return false if parent count is less than 0. And your I, so your I is going to be, so in general, when you have this type of construction in a method, I would say this is okay. You have a guard clause at the top of the method, early return, and then you have a return at the bottom of the method. And to me, those are the two places where it makes the most sense to have a return. What's sometimes problematic is if you have a bunch of if-elses in the middle of your method and embedded in there is a return, it becomes really hard to read the method. So in general, I would say guard clauses at the top and then a return at the bottom of the method. This isn't exactly the very bottom, so that's why I said saving it to a variable may be okay, not necessarily the worst idea. But because this is already sort of at the last line, and your eye kind of goes there anyway. What you want to try to avoid is if you have a return sort of in the middle, a return at the very end, then that becomes a little bit harder to think about. But this is good. I think this is fine. Otherwise, I suppose we probably want some, like a last thing, right? Otherwise, it's going to return. I guess this will return true because this will return the each will return the array here. right? And so this is also kind of hard to see. But, well, no, actually, if it's balanced, it's always going to return. Wait, if it's balanced, is it going to return true? Is it going to return true ever?
I think if it's balanced, it's going to return
So here I have to put
the string.
perhaps. Yeah.
Yeah, we'd need to put a final return statement. Otherwise, it's not actually going to return true.
Right. So I guess I just violated what I just said, which is that you have 3 places now. Even this is maybe okay. I would say this is not the end of the world, but having a variable there is okay too, right? So failure equals false, or success equals true, right? Set success to false and then return that. That might work too. So yeah, in general, I think this code is fine. Cool. Any questions from the audience about this exercise? I think once you, and again, I kind of helped here in terms of giving the approach, and this is why the test here isn't really, are you smart enough to think about this trick on the fly, right? That's not, we're not trying to be tricky here. The goal here is to see, can you code the ideas you have in your head very quickly, right? Can you code it up real quick? So it's I guess these particular exercises, I would want the focus to be on practicing fluency and making sure you can move forward. And obviously there's a little bit of tricks here and there, but that's actually not the most important part. It's can you code up your ideas, right? Try this, try that, and see if you can eventually get to it. Yeah, somebody's saying, can I do return true on line 28? That's fine too. That's just an implicit return. Okay, I have one more exercise here. Give that a read, Conrad.
Okay.
Okay, so don't use the built-in prime class. So this implies you have to probably write your own.
Okay. Create a couple test cases first. That's probably good to start for now. We could add some more later. I'll just start by defining the method again. Find primes. We'll call it start and stop numbers. And then it's going to print out all the primes between the 2 numbers. I think we'll iterate through a range. We'll just use the start and the stop your range. And I'll go ahead and I'll use select on those. We'll select out the numbers that meet the criteria to make them a prime number. A number for the block parameter. And then I'm going to check if the number is prime. The basic definition of a prime number is it's only divisible by 1 and itself, right? Am I correct on that?
Right.
Okay. My first thought is to use another internal loop inside the select method. We could do use the up to method. Let me check the docs on that. It's a method, if I remember correctly, you can.
You're checking up to?
Yeah.
Yep.
let me see. I'm trying to remember, there's a Ruby method that lets you get a range starting from one number up to a max number.
Yeah, that would be up to, or a range.
Okay. Let me check IRB real quick.
Or you can just write a loop
Up to,
manually.
We'll just use a range. So we're iterating through every number from the start to the stop, and then within each of those iterations, I'll just go ahead and use another range. We'll do 2 to the number -1. I'll do another. Let's see here. Let me check that in IRB, make sure I'm doing that syntax right. Oh, I've got it in there. It doesn't know what number is. 10. So 2, 3, 4, 5, 6, 7, 9. Okay, so that is the range that I want.
So the algorithm I think you're going for is you're going to iterate through every single number from 2 to up to the number less than 1. And if there's anything that's divisible there, then it's not a prime.
Correct. If I find one that divides evenly into our current number, I'm just going to break and return.
Right. And this exercise is like an exercise within an exercise, right? So now you're in the second exercise, which is trying to figure out whether or not a number is prime.
Yeah.
Okay.
Okay. So we'll just do dot each, call it divisor. Two. And I'm at this point, I'm checking if the divisor, if the number modulo divisor is equal to 0. If that's true, then I want to break and return false. So we're nested a little bit here. If I hit break, if I call break here, we're just going to break out of this iteration of this divisor iterator, but I don't actually want to do that. I want to break out of the select method, and I want to turn false from the select method. I'm not sure how to do that though.
There is a way in Ruby.
I think.
But whenever you run into this type of situation, it's probably easier to extract to a method, and this method can then return. You're absolutely right in that. I'm glad that you caught that, Conrad. I don't know that a lot of beginners would. Is in that if you return there, it's going to return out of the method, and you don't want to do that. It's almost like, but you break, you're going to break out of this each, but you want to break out of the select. So it's really a weird situation, right? So what I would suggest is to perform the calculation. This is a natural extraction to another method, right? Determine whether or not a number is prime in a separate method, and all that method should do is return true or false.
Okay, that makes a lot of sense. Well, it is prime, and it's just going to take one number.
And you can even just hard code, true or false if it's odd. You know what I mean? Just kind of put some random logic in there for now, and so that you can focus on one thing at a time. Because you got two things going on right now.
Yeah. I think for now I'll just have it always return false, and then we'll actually add the logic for is prime later. So this chunk right here because I want to actually save the work I did there, because that might be good to implement something like that in is prime. I'll stick it in is prime and then comment it out, and we'll come back to is prime later. So we're back here iterating again. We want to check, and right here, I'm just going to make a call to is prime and give it the number. Is prime is going to return either true or false, and the select method is just going to keep whatever returns true. So let's see, because is prime is always returning false, if we run this code now, find primes, both of these test cases shouldn't return any results. They shouldn't find any primes. This is a I think that's
And, just for testing purposes, you might, rely on the built-in prime method just to check it out. Or like I said, you can just kind of code some random thing there so you don't get an empty array, right? Like, give me all the, odds. Those are going to be the primes for now.
Okay. Well, let's see what is prime does if I change it to true. Now we should get an array of every number within these ranges that we've passed in. 3, 4, 5, 6, 7, 8, 9, 5 to 20. Okay. So I'm pretty sure that this call to is prime is working correctly. Now we just need to add the logic to is prime, and I think that will work fine.
Mm-hmm.
So I think I'm going to keep this range iterator. There's probably a more elegant way to do that, but I think it works fine for now. And we're just going to return false if number modulo divisor is equal to 0. So
right.
If we find...
this is saying, I'm going to iterate between 2 and 1 less than number.
Mm-hmm.
And if I find a divisor between that range, then obviously it's not a prime. Right? So I'm going to exit out of this method, return false. Right?
Yep.
Okay.
And if this return statement on line 11 never gets executed, then we'll reach this one. We can return true, and I'll just put true, because we know if we get all the way through this iterator from lines 10 to 12 and we've never returned false, then we didn't find a divisor outside of the number in itself. So that would...
Right.
So we know that it must be a prime.
Right. And notice that if you didn't put line 14, I think your code would still work, but incidentally, right? Not intentionally.
Right. It would still return a truthy value, but...
A truthy value, which is what select uses. Right. But you don't want to code that way, right? You want to make sure that you're coding with intention all the time. So I'm glad that you caught that.
Okay. Yeah. So let's run that and see what that looks like. 3, 5, 7, 3, 5, 7, 13, 17, 19. So that looks good. It looks like it's giving us good output there.
Yeah, perfect.
If we add I don't know what it will do if we give it some like edge case like 1 and 2. I don't know if 2 is going to work right. It's fine.
Yeah, it looked like it did great. So I think you did really great here. I think you kind of got into this coding, the calculation of prime within this loop. I'm actually glad that you did that, because I was able to help point out the extraction to a method, because I was afraid that you were going to just recognize that. Because I see people do this all the time, where they're sort of nesting logic inside of another larger iteration, and then kind of exactly the situation you got in, which is, now how do I control the nested sequence? I want to exit out of this iteration, but not that one, right? Or I want to exit out of the top level one, but not exit out of the method or return out of the method. So there is a way to do that in Ruby, but that's like go-to programming. You want to try to avoid that as much as possible. So extracting to a method usually in that case is the right thing to do. Otherwise, again, I'll just kind of keep harping on this, and I'll kind of switch my context back to the audience who are listening, is that Conrad was only able to sort of work his way through this problem. You can see that even being fluent in Ruby doesn't really mean you can solve problems very quickly. It just means that it gives you the ability to move almost as quickly as you can think. Right? So he was thinking this algorithm of calculating a prime very quickly in his head. If he had not been as fluent in Ruby, it would have been a struggle just to kind of get this going, right? But because he knows how to work with ranges, and he looked up to just the movement of that particular little problem the problem was solved very quickly. So whenever you're tackling an exercise like this, you're just going to run into maybe a dozen little problems. And if the fluency isn't there, every single one of those little dozen problems is going to be a stumbling block. And I think that's what's really frustrating. And it's really, when, let's say, at a job interview where you're doing it in front of somebody, it's really nerve-wracking and it's really hard to recover. So, well, great job, Conrad. I don't have any other exercises. Any other questions or thoughts from those of you listening in? All right, getting some kudos for you, Conrad, saying very impressive, so I would concur with that. I would definitely agree. Very impressive performance, no real hiccups, and everything went really smooth. But I would just say that I think it's really because of the fact that we were able to stay at the logical level and not worry about the syntax, right? In these sessions, I always say, run your code, run your code, run your code. I didn't have to do that very much today because there wasn't really any mistakes or little grammar mistakes or little syntax mistakes. But early in the process, you're gonna encounter that a lot, and you have to be okay with that process until you get here. All right, guys, that's it for today then, and have a good rest of the weekend. Thanks again, Conrad.
Thank you.